All right, so we are doing pSAT review because the SAT is coming up on Wednesday. Today's date is Thursday, October 10th, 2019. Number 6. So we have this function that says h is equal to 3a plus 28.6. We also know that a pediatrician, a doctor that does stuff with, a doctor that helps kids, I guess, uses the model above to estimate the height of a boy. So h represents the height of the boy in inches. In terms of the boy's age in years. There's too much talking. Between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? The correct answer here is A.
Oh, Mr. Shimon, A.
Let me talk about why the answer is A.
Well, it's quite simple, actually.
Well, it's quite simple, actually. So if I have 3 attached to the variable A, 3 is the slope. Again, write this down. Slope is the number next to the variable. This is very informal. I should be saying that slope is the coefficient in the equation. The coefficient, again, is the number next to the variable. So if my slope is 3 and my units are inches every A years, then my slope is 3 inches per year, which is exactly what the question is asking. Based on the model, was the estimated increase of the boy's height each year, height in inches each year. Since 3 is being multiplied by A is years, this is inches per year. So the correct answer is A, inches per year, 3 inches per year. Ask me questions now, Gunnar Hood.
It's really wait. So would any of these numbers be H, or it would just be A?
None of the, I mean, if I plugged in, if I wanted to find the actual increase in height between 2 and 5, then I would be adding 5 minus 2, which is 3 plus 1 because they're a total of 4 years. If I go from 2, 3, 4, 5, oh, I guess it's not including 2. So I'm increasing by 3 years. I could do 3, plug it in for A, and I get 3 times 3 when I'm plugging 3 in for A, the total increase. And then I would add 9 to 28.6, and I get 37.6, which isn't any answer. But the total...
What if you just do 5 minus 2?
5 minus 2 is the number of years that you change in this interval.
But that's the answer too.
It happens to also be the answer.
Okay.
That's not what it's asking for, though.
Okay.
Let's go to number 7. Alright, so we have this really crazy formula. So the formula above gives the monthly payment M. So this all represents a monthly payment because it's equal to M. Needed to pay off P dollars. So there's P. I'm going to multiply this giant fraction by however much I have to pay off, P dollars, at R percent. Notice the R percent is in here multiple times. This is the percent of annual interest over N months. So N months, the time is in the power up here. Which of the following gives P in terms of M, R, and N? So I now need to think of this thing as a giant fraction. Let's think as this top, all of this is just A. Ignore all of this, and this is all B. So what I essentially have is M is equal to A divided by B times capital P. That's what I'm boiling this formula down to. Can we all agree, if I assume that the top is A, the bottom is B, I can rewrite it like this. We can nod our heads. That's how you can rewrite it. I make it much more simple. Okay, if I want to get P by itself, what do I need to do? Right now, P is being multiplied by A divided by B. Quiet raised hand. What am I going to do to undo multiply by A divided by B? Sergio?
Times A divided by B. Both sides.
So right now it's being multiplied, so the inverse operation to multiply, Sergio, is... Yeah, so I'm going to divide both sides by A divided by B. Divide by A over B, divide by A over B. A over B. And then I get my answer. So P is equal to A divided by, P is equal to M divided by A over B. I'm going to pause right here because I switched sides. So far, so good. I'm dividing both sides by A divided by B, so these are to cross off. I just left with P. On the left-hand side, I have M divided by A divided by B. m divided by a over b. So far so good? Nothing magical has happened yet? Alright, this is where I consider the magic to happen, where if I divide by a fraction, do you guys know that keep it, change it, flip it, keep it, change it, flip it? So this is going to be p is equal to keep it, change it, flip it. There it is. And then we know what b is. B is this bottom part, so b should be on the top. Which one of these has this bottom thing on the top now? It's not A. B has it. It's not C, and it's not D. Just by doing that simple logic, we know that the answer is B.
Well, Mr. Pemdas, are these types of problems going to be on this, like the actual SAT?
Yes.
The exact numbers or different numbers?
Different numbers. They
But
don't
same
reset.
type- but same types of problems.
Same types of problems. Yep. Sergio,
If you take the SAT math, would you get 100%?
would I get 100%? Probably not. Because I haven't studied the SAT as enough.
Well, you know all the math.
So now, why don't the
answers.
teachers take the SAT?
Yeah.
While the students are taking
It would be
The
interesting to see what
SAT,
happens.
The teacher SAT.
Yeah.
It's called the GRE for the teacher.
GRE. Oh, then why don't you take the GRE?
The
I
GER?
did.
Why don't you not take the GER?
I did take the GRE.
Why don't you take the GER while we're taking the SAT?
I was doing that a while back. All right, we're on to number 8. If a divided by b is equal to 2, what happens when I do 4b divided by a? So, we're going to set this up. Let's just go ahead and choose numbers. These ones are nice and easy. Let's choose a number of a. A is equal to b is equal to. Someone give me something that makes this true. If I do a divided by b is equal to 2, someone with a quiet raised hand, tell me 2 possibilities. A and b are what? I'll give you one, but you can't copy it. I'm going to say A is 8 and B is 4. Check that out. 8 divided by 4 is 2. Woo! Give me another one. One of you. Jose. 4 and 2. There it is. Let's just say, assume that Jose has it correct. 4 and 2. Well, now let's switch it. If B is 2, I'm going to say up here it's going to be 4 times 2. And then Jose said A is 4, so there's 4. What's 4 times 2 divided by 4?
Oh,
4 times 2 is?
8.
8 divided by 4 is?
2.
There it is. C. Sometimes it's easiest just to pull out numbers that work.
Let me process this in my brain.
I could have chosen 2 and 1. That would have been the easiest one. 2 and 1. 2 divided by 1 is definitely 2. It still would have worked, because then I would have had 4 times 1 divided by 2. That's 4 divided by 2. 4 divided by 2 is 2. I choose numbers that work. All right. On to number 9. Solution to the system of equations. Oh wow, this looks like what we did last year, where we did elimination and substitution and all that. So the main thing to notice here is that the y's are switched, so it's kind of diagonal. So I'm going to rewrite this bottom equation as negative x plus 2y is equal to negative 19. It's the same thing. It's using the commutative property of addition, where I switch the negative x and the 2y. So ignore this equation now. I switched out this bottom equation just by switching the order of the x's and the y's. Is anyone not okay with this? Does anyone want to ask a question? Okay, then from now on I'm going to scratch out this equation and ignore it. Alright, what do I need to multiply this bottom equation by on both sides in order to eliminate one of the variables? I think elimination is the way to go with this one. You could do substitution, it's a little bit harder. How could I match up opposites? 3 with negative 3 or 4 with negative 4. How could I multiply the bottom by something on both sides, Fernando?
You can multiply it by 2. So the 2y becomes 4.
Yeah, so let's go ahead and do that. If I multiply by 2, oh, I have a 4 and 4. Can I make this one a negative 4 somehow? I want to do opposites, 4 and negative 4. Ah, let's make it a negative 2. So this is one possible way to do it. So if I multiply the whole bottom equation by negative 2 on both sides, I'm going to rewrite that. Negative 2 times negative x is a positive 2x. I'll pause there. Negative 2 times negative x is a positive 2x. Negative times a negative is a positive. 2 times the hidden coefficient here is 1. 2 times 1 is 2, and I still have the x. Next, I have negative 2 times positive 2y to get negative 4y. And finally, I have to do negative 2 times negative 19. Well, a negative times a negative is a positive, and now I just need to do 19 times 2. 19 times 2 is 38. So now I can kind of ignore this equation and just look at these two equations. If I add them together, if I add 3x with 2x, 4y with negative 4y, negative 23 with 38, then I should be able to eliminate the y variable. Let's try it out. So I'm going to add 3x and 2x and shout it out. I get
1x or just x?
3 plus 2 is,
Plus
yeah, I'm adding these together.
5x, yeah.
5x, thank you. 4y minus 4y, quiet raise hand for this one instead of shouting it out because it seems like we're not quite there at shouting out. 4 minus 4, Cohen? 0, it's gone. So eliminate, it's gone. Don't even worry about it. Thank you, Cohen. Is our game warden getting all of these?
Oh, yeah.
Oh, yeah. And then what about negative 23 plus 38? Or 38 minus 23? 8 minus 3, 3 minus 2. What is negative 23 plus 38? I'm adding the right-hand side. Sergio?
Oh, wait, no,
15. I added equation 1 with equation 2, and I got equation 3. From there, I just need to solve. Divide both sides by 5. So divide by 5, divide by 5, and I get x is equal to 3. Which of these has an x coordinate equal to 3? There it is. And we can check it as well, but for the SAT, it's all about speed. It's all about knowing the tricks and the shortcuts. It's not about checking your work, which means that it's not really a true math test in my opinion, but there it is. Sergio?
But math is not about speed.
I 100% agree, and that's why I think that the SAT is a bad test.
So let's not do it.
I mean, I agree with Julian too.
Let's go. Let's go.
But unfortunately, there are too many colleges and universities that still judge you on how well you can do on the SAT because it is indicative of how well you can study. If you can study for the SAT, then they assume that you can study to do well in college. This is a measure of how well you'll be successful in college. If you can study for the SAT, you can study in college, you'll be successful in college. Does everyone understand the type of logic that they're trying to use? Yeah, I know. It's flawed. Every test that I've ever taken is flawed in some way. I don't think there's any perfect test. SAT isn't even a close test to something perfect. Let's do number 10. For the function g defined above, a is a constant. So we're assuming that a is some number. Whenever I see the word constant, just think of the word number. A is like a number. And g of 4 is equal to 8. Whew. Function notation. I know that a lot of students don't like this, but what this is saying, when I say g of 4 is equal to 8, it's saying that one of the answers is 4, 8. 4, 8 is an answer. That's what this turns into. It's saying that the x coordinate is 4 and the y coordinate is 8. X coordinate is 4, y coordinate is 8. That's what g of 4 is equal to 8 translates as. Choose x to be 4 and y to be 8. And it's saying, okay, well, what will happen now if I choose x to be negative 4? What will happen? I want to make sure that everyone understands the question. The question is saying, if I plug in 4 for x and 8 for y, that works. Then I need to, after figuring that out, I need to figure out what negative 4 is. So the first thing I'm going to do, I'm going to plug in these and see what happens. I'm plugging in 4 for x. So I'm saying g of 4, remember that x here is 4. G of 4 on the left-hand side. On the right-hand side, everywhere that you see an x, x is 4. X is 4, so I have a 4 squared plus 24. But I also know what g of 4 is equal to. What is g of 4? It just told us on this line right here. G of 4 is, Jose?
8.
It's 8. So change this left-hand side to 8. And on the right-hand side, 4 squared, shout it out, everyone, is 16. So that means 8 is going to be equal to 16, and I can't do anything with the a yet, so I'm going to leave a. 16a plus 24. Oh, this looks like now I could solve for a and figure out what it is. I could figure out what a is, and then after I'm done with that, go ahead and plug in negative 4 again to see what pops out. So let's solve for a. Solving for a, I'm going to subtract 24 from both sides. What is 8 minus 24? Andres?
Negative 16.
It is indeed negative 16. Which means negative 16 is still equal to 16a on the right-hand side. That's what remains after I eliminate these 24s. What is my final step to isolate a? What do I do to both sides to isolate a? Sergio? Careful, 16 is being multiplied by a right here. Divide both sides by? There it is. And Sergio, what is negative 16 divided by 16? It's 1, but negative divided by positive is a negative. So a is equal to negative 1. I'll pause here. I'm going to review exactly what we just did. What we said was, we need to understand what g of 4 is equal to 8 means. It means I'm plugging in 4 and 8. And that says that is an answer. So we plugged in 4 and 8. So everywhere where I see an x, change it to a 4. Everywhere I see an x, change it to a 4. But we also know that this is kind of like the y. I can think of this as y equals ax squared plus 24. In fact, can we all write that down? Change this to y equals ax squared plus 24. That's essentially what this is saying. It's just a different way of saying it. This is saying that y is equal to ax squared plus 24. It's the same thing, which means I could have, if I understood what it was asking, if this is y, this is y, 8 is y, I could put 8 in immediately. So I've substituted everything into my equation, then I'm going to solve for a, because a is some random number. A is a number. A is a constant. We're solving for a, and we boil down the math. This is just simple algebra 1 operations. And I get a is equal to negative 1. Now what we're going to do is we're going to rewrite this equation, but instead of an a, we write negative 1. I'm going to rewrite this equation and then plug in negative 4 for x to see what y is going to be. Here we go. I'm running out of room here. So I'm going to rewrite this equation over here on the right-hand side. So I'm now going to write y is equal to negative 1x squared plus 24. I substituted negative 1 in for a. Now it's saying plug in negative 4. G of negative 4 says plug in negative 4. What y coordinate do you get? So y is equal to negative 1 times, I'm plugging in negative 4 here. So I'll write this in a different color to make it pop. Negative 4 squared plus 24. Negative 4 squared. Negative 4 times negative 4 is?
16.
Is it positive or negative 16 for just this right here? Positive 16. What's a positive 16 times a negative 1?
Yeah, 16.
So this now turns into negative 16 plus 24. That's what y is equal to. And then finally I have to do, what is negative 16 plus 24? Y is equal to correct answer is A. Question, Sergio.
Could you do like negative 1 times negative 4?
No. So order of operations using PEMDAS. PEMDAS states you do parentheses first, nothing to do there. Exponents next, and then multiplication. Good question. By the way, what's crazy about this problem is they expect you to do this problem in 1 minute.
What you mean?
The SAT expects you to do these problems without a calculator about a little over a minute, but generally a minute per question.
Wait, are we allowed to say BS? Like, not the actual thing, just BS?
I would prefer that you didn't.
I could do it in a few seconds with math.
This is what it means to study for the SAT. Doing these problems so often that you just do them automatically.
I feel like that's a lot.
It is very
I
stressful.
want to see someone doing it.
Me explaining it to you definitely slows me down, but I could probably do this problem in about 30 seconds because I've trained so long for these problems.
No, without Mathway?
Without Mathway.
Without.
Wait, can we use Mathway on the SAT? Because it's not.
Haha, no. All right, number 11. We have these two equations. In the equations above, B and C represent the price per pound in dollars. So these represent money. Money per pound in dollars of beef and chicken, respectively. So beef for B, C for chicken. Makes sense so far. I got some weird errors happening here. Respectively, X weeks after July 1st. So X represents time, where I do time since July 1st, during the last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So what I'm going to do here is I'm going to set these two equations equal to each other, saying that their prices are equal to each other. If I say that B is equal to C, that's saying that the price of beef and the price of chicken are the same. The price per pound of chicken and the price per pound of beef are equal. That's what I'm saying by saying B is equal to C. Well, what is B? What is C? Well, B is 2.35 plus 0.25x. That was B, is equal to C. And what is C? C is 1.75, I ran out of room here, 1.75 plus 0.4x. And then I'm solving. When I solve, I won't be done. What does x represent? Can anyone read the problem and give me a quiet raised hand? I'm solving for x, so I'll get an answer for x. What did I just find? Once I solve for x, what is x? It's somewhere in this, if you can read it. I need more hands, more hands, more hands. What is x, Gunnar, laptop? What is x, Andres?
The weeks after July 1st during last summer.
Exactly. X is the weeks after July 1st during last summer. Is that what it's asking to?
No.
It's asking what is the price. So once I find x, I need to plug it back into either equation to find the actual price. Here I go. I'm solving.
At least 5.
I'm rewriting the problem so I have more room. 2.35 plus 0.25x. That is going to be equal to 1.75 plus 0.4x. I'm going to solve for x first. I'm going to subtract 0.25x from both sides. And again, your tip for the SAT or the pSAT is you don't need to show your work on this. If you can do this in your head and you can say minus 0.25x on both sides, then I'm going to write 2.35, these are gone, is equal to 1.75, and then it's going to be 0.15x. If you can't do that in your head, then obviously you might need to show your work. Andres?
Oh, I have a question.
Yeah.
So what if you just guess on every answer but get them all right? Like,
So
you can do that, right?
I mean, it's possible, but very, very unlikely. Should I tell you why it's unlikely?
Why?
So go to your bubbles. How many questions are there?
Wait, in SAT, there's
So just in section 3, there are 20 questions, which means each question has 4 possibilities. So your probability of getting all of them right is 1 over 4 to the power of 20.
What if you like?
Just on section 3, if there are 100 questions, it's 1 over 4 to the power of 100. So what is 1 divided by 4 to the power of 20? So, and then I have to multiply by 100 to change it into a percent. You have, with 10 zeros in front of this, you have 0.1, 2, 3, 4, 5, 6, 7, 8. Oh, it went away.
But there's still a small possibility.
0.9% chance of getting them all right just on section 3 if you guess on all of them.
But what if you just what? But what if you just like get the best of luck in the world and just get like all of them correct?
All right, I'm done talking about this because you see how unlikely it is.
don't think I'm gonna do that.
From here, I'm going to subtract by 1.75 on both sides. When I subtract by 1.75, it's kind of hard to do, so I'm going to have to write this out. So this goes to 0. I can't do this, so I have to borrow. This is now 13. 13 minus 7 is going to be 6, so 0.60. So I now have 0.60 is equal to 0.15x. And a good trick here is to multiply both sides by 100. I'm just allowed, as long as you move decimal places 1, 2 on this side, you can move them 1, 2 on this side. Yeah. So now I have the equation 60 is equal to 15x. Divide both sides by 15, I get x is equal to 4, which is not the answer. Because again, I found that after 4 weeks they'll be the same price, but now I have to plug x back into one of the equations. I see that this is 0.25, and I know if I have 4 quarters that'll be $1, so I'm going to plug back into 0.25. When I plug 4 back into here, 4 times 0.25 is 1. 1 plus 2.35 is 3.35. Correct answer is D.
I guessed that in that one and I got it right.
Nice. It happens 25% of the time.
No, but I can do that during the whole test.
And then you'll get 25%. Yes. On average. All right.
What's the average score on this? The SAT?
So it's a bell curve. So if it's out of 1,600 points, the average score is 800. Yeah. And if you guess, you'll get 400.
What if you get
What
it
if
right?
you
What
guess
if you
like
guess?
1,600?
Yeah.
Doesn't happen very often. It happens 0.000000009% of the time.
But it could happen
So
to
My
you.
chances are high.
Yeah. My chances.
Like I've had 0.00000000001 chances and I've got it.
Good.
Number 12. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lie on that line?
It's B.
So if I were to draw a quick sketch of what's happening, it passes through the origin, which means this is a point right here. I don't know why that does that. And it has a slope of 1/7. Is 1/7 like that or like that? Is it the first one or the second one?
No, it's C.
It's nice and flat.
It's C.
Which of these makes sense? 7/7 is right about here. That doesn't make sense. 14/2 is way over here. That could be on it. 1/7 is right about here.
It's 0.7.
0.7 is right about here. So it's not 0.7. That's too far up.
No, you got it right.
Oh wait, 14/2. 1/7 is not there. 1/7 is up here. So get rid of that point. The only point that makes sense is 14/2. So just by doing a quick sketch, you can get it.
They pulled the trick on us.
Oh, okay. I get it.
They did double D's back to back.
So it's not B. 1/7 is right there, which isn't on this line. If it was 7/1, then it would have been correct.
Wait, but how would you know, Mr. Sindel?
How would I know what?
How would you know where the points are located at?
I'm just doing a rough sketch.
Oh.
On my rough sketch, I know that my slope is very not slopey. It's very much like almost a flat plane. It's a very non-steep hill.
How would you know that?
1/7. All right, let's try this activity right now. Everyone, get your arms ready. Warm them up. Warm them up. Warm them up.
Do that line.
All right, so I want you guys to only use your right arm and tell me what does a slope of 1 roughly look like. Go. Slope of 1. Go. Slope of 1. No. No.
Oh.
Slope of 1. Close. No. Slope of 1 looks like this.
I got that.
I was doing that. What do you mean?
Wait, Gunner.
Yeah, that's what I was doing.
Okay. Do that again.
Sorry.
Do a slope of 0. Go. Slope of 0.
0.
It's down here. Do a slope of -2.
I'll make it.
Do a slope of 13. You guys now know how to sketch a graph. That's exactly what I did. I said, now let's try this one more time. Slope of 1/7. It's basically 0. It's 0, but a little bit more.
1/7.
I'm graphing my graph.
That's what I did. I made my sketch.
My arm hurts now.
All right. Number 13.
Why'd you quit?
which of these are equivalent to each other? Or sorry, which of these is equivalent to this fraction right here? This guy is very difficult. So I know that I think one person has solved number 13 already. I think it was just Fernando. So this looks difficult. So what you have to do for this problem is you have to add these bottoms. But I can't do that because they're not like denominators. So if I have 1 over x plus 2, it's missing an x plus 3, so I can multiply the top and bottom by x plus 3. 1 over x plus 3 is missing x plus 2, so I can multiply by x plus 2 on the top and the bottom. Again, I'm ignoring the top here. I'm only dealing with the denominator. How do I add these things? Well, I can't because they don't have like denominators. In order to get like denominators, I need to multiply 1 over x plus 2 by the thing that I'm missing, x plus 3 over x plus 3. In order to get this with a like denominator, in order to get this 1 over x plus 3, I need to multiply by what it's missing, namely x plus 2 over x plus 2. So, this new denominator looks like this. The new denominator is x plus 3 on the top. 1 times x plus 3 is just x plus 3. And on the bottom, I need to multiply these together. We've done this before where we multiply polynomials. The easiest way to do this is an area model, but you should be able to do these in your head for the SAT. If you want a high score on the SAT, you should be able to do these in your head. And you should be able to say, oh yeah, that's x squared plus 5x plus 6. The way that you can do that in your head is add 2 and 3, that's the middle number. Multiply 2 and 3, and that's the last number. I'm trying to show you guys shortcuts. You don't need to know them for my class, but you should know them for the SAT.
Mr. Shindo,
Yes.
what if you cheat on the SAT? Like, what will happen?
I mean, if you don't get caught, then nothing happens.
But if you get caught?
I don't know. I've never done it. I've never even thought about doing it.
Why? You don't get caught.
Probably really bad things.
That's the only thought that goes through my mind.
If I add this to my second fraction, I need to multiply 1 times x plus 2. 1 times x plus 2 is just x plus 2. The denominator should be the same because I'm multiplying x plus 3 times x plus 2. X plus 3 times x plus 2. It's the same thing. So I should be getting x squared plus 5x plus 6. And then I just need to add the tops. 2x plus 5 on the top, and the bottom is x squared plus 5x plus 6. This fraction that I've written right here is equivalent to the denominator. I haven't touched the numerator. Are you guys ready for the cool little trick for the numerator? This numerator can be rewritten as 1 over 1. Do we all agree that? So what I'm saying here, this is asking what is 1 over 1 divided by the denominator. Which is saying what is 1 over 1 divided by this denominator, divided by 2x plus 5 over x squared plus 5x plus 6. What happens when we divide fractions? Keep it. There it is. Keep it, change it, flip it. Keep it. Good. 1 times. So it's 1 times, flip it. X squared plus 5x plus 6 all over 2x plus 5. 1 times anything is itself. So there's the answer. X squared plus 5x plus 6 over 2x plus 5. And there it is, B.
Wait, when did you say the pSAT was?
Wednesday.
Next one.
This upcoming Wednesday. So if I saw this problem on the SAT and I was Mr. Sindel, who has lots and lots of knowledge about mathematics, I could do this problem in roughly 2 seconds. Because I know the trick. If I ever see 1 divided by anything that has fractions in it, anything that has fractions in it. I know I'm going to be taking the reciprocal, and I know that when I add these, I should be getting some sort of fraction. So I immediately would eliminate C and D within the first second, and in the second second I would say, oh, well, I know that the numerator is going to be less complex than the denominator, and I know that I'm going to have to flip it because it's 1 divided by the flipping. Which one looks more complex? The x squared plus 5x plus 6 or the 2x plus 5?
The x squared plus 5x.
I know that the x squared plus 5x plus 6 looks more complex. It should be in the denominator, but I should be flipping it because there's a 1 here, so I would immediately get B just by knowing all of those facts. I wouldn't have to do any math at all. I would just look at what looks more complex.
No, that's at least 45
Dude,
seconds.
he's a genius, Gunner.
I had to explain my work, which takes time.
Okay, well, I still don't believe that you can do it that quick. I actually have to see it.
See to believe it.
Video no.
Video didn't have it.
All right, we're on number 14. This guy is more complex. This one would take me at least 40 seconds. So, 3x minus y is equal to 12. What is the value of this thing? So, again, this is the easiest type of problem where you just substitute in numbers.
It's C.
It's B. It's 4 x minus y.
So, for this one, choose some numbers that work. What's some numbers for x and y that work?
4.
4 and...
3.
No, that doesn't work.
2. 0.
3 times 4 is 12, minus 0 is 12. Do we all agree that these numbers work?
Yeah.
Okay, then let's come back over here. 8 to the power of 4 over 2 to the power of 0. That is a big, big number. This one requires rules of exponents, unfortunately.
Wow.
So I'm realizing this is not the quickest way to do it anymore. I mean, you can do it this way, but I'm going to have to do some tricky math. 2 to the power of what is equal to 8? 2 to the power of 2 is 4.
4.
2 to the power of 4 is 16. 2 to the power of 3 is 8. How does that help me, Mr. Sindel? Well, it helps you because you can rewrite this thing. Let me write it down here. I have 8 to the power of x divided by 2 to the power of y. Well, this 8 right here can be rewritten as 2 to the power of 3 to the power of x, all divided by 2 to the power of y. Do we agree that 8 is 2 to the power of 3? 2 times 2 times 2 is 8? That means 8 is 2 to the power of 3, and then 8 is to the power of x, so 2 to the power of 3 is to the power of x.
Wait. Wait. X.
You guys have told me 2 to the power of 3 is 8.
Yes.
That means this 8 is being substituted out for 2 to the power of 3.
Oh.
So would X be 4? Since we used 4.
I'm not quite there yet.
Oh, okay.
One of the rules of exponents that we have very briefly talked about that we'll definitely get more in depth in Algebra 2 is whenever I have something, let's say I have x to the power of a, and I take that to the power of b, this is equal to x to the power of a times b. If I have an exponent and an exponent, I multiply those exponents. It's just one of the many rules of exponents that you need to know. And it's not many, there's like 5 of them that you need to know. That means I can rewrite this as 2 to the power of 3x divided by 2 to the power of y. I don't know what you mean by that. Another rule of exponents that you need to know is what happens when I do division. One of your rules of exponents, all the way back, it was like lesson 13-7 or something, I don't even remember, is if I have x to the a divided by x to the b, this is equal to x to the a minus b, which means if I have the same bases, and I have powers, subtract the powers. So this now, coming down here, is equal to 2 to the power of 3x minus y. Oh look, I see 3x minus y somewhere else in the problem. 3x minus y and 3x minus y are both right there. What can I substitute out for 3x minus y?
3x minus
I mean, I could. That isn't going to help me. Jose?
12.
12. 3x minus y is 12, so this now can be equal to 2 to the power of 12.
Wow.
Mathemagical.
Wait.
I used 2 rules of exponents. I first used the rule of exponents where I did a power to a power, and I got 3x. The next rule of exponents that I used was if I have a base divided by a base with the same bases, I can subtract the powers. Yeah, it's hard. You guys have never studied for the SAT, so this is all brand new, and it looks like it's impossible.
Why didn't we do this in elementary school?
Yeah, why? We did
Fail, though.
kind of. We did go
No,
through
instead
that.
of learning
in
how
that
to
test.
read. Right.
So you might be asking, if you are dedicated and you're actually curious about this problem, you might be asking, well, Mr. Sindel, how did you know to turn 8 into 2 to the power of 3? I knew that I would need to use rules of exponents because there's no way to make this look nice. And I've also done problems enough where I see 8 to the power of something, 2 to the power of something. I know that I need to make this 2 to the power of something, so I have 2 to the power of something. I know that I'm going to be using rules of exponents, so I need to somehow convert both of these to the same base. The only way to do that is to turn 8 into 2 to the power of something. I'm like, oh, 8 is 2 to the power of something. 8 is 2 to the power of 3, and then that's where you start working. Again, once you see this problem for the 6th time, you'll probably get it down. But you need to practice. That's why the SAT only works if you practice and study. If you don't want to practice and study, then you're not going to get a good score, but that's your choice.
Right. Wait, so the pSAT doesn't count, like doesn't affect your grade?
It doesn't affect your grade, it affects your college admission.
The pSAT?
The SAT.
But not the pSAT.
pSAT is just practice for the SAT. What is it like? And you'll realize, wow, it was really hard, and you need to know all the tricks in order to get all the problems done in time. Otherwise, I'm just guessing the last 6.
Wait, Mr. Sindel, can I hire you as a tutor and pay you more than what SASA pays you?
You may hire me as a tutor, and we can talk about rates whenever.
So I'll pay you $100 an hour.
That is
illegal.
a normal price, actually.
Alright, $200 an hour.
$200 an hour?
$500.
Sure.
$700.
I'll take it.
$200 an hour, period. Take it or leave it.
$500.
I'll take it. All right, number 16 is actually one of the easier problems on here. Here we have an equation. We'll use this fact that t is positive later. We have this equation. What am I going to do to this equation to solve for t? I need to undo, subtract 4. What am I going to do? Quiet raised hand. What am I going to do to both sides? Jose. There it is, plus 4 on both sides. And I get t is equal to, or sorry, t squared is equal to 4. How do I undo a square? Cohen. Square root both sides. Here it is. So therefore, t is equal to not 2. If you just write 2, you get 50% off on my test. But on the SAT, you would actually accidentally get it right.
T equals 2?
T is equal to plus or minus 2 because t could have been negative 2 because negative 2 times negative 2 is positive 4. But it also could have been 2 times 2. Then you use the fact that t is bigger than 0 to know that t is normal 2. The answer here is just 2. For homework tonight, answer the rest of packet 3. We're starting on packet number 4 tomorrow. Answer questions all the way from 16 to 20. We just did 16, so you have 17, 18, 19, 20. You have 4 homework problems tonight. Do your homework. Otherwise, you're losing more HP.